Hi everybody, welcome to Scientific Methods, Lesson 3. This is the explanation part, and we're going to be focusing on hypotheses today. Now, hopefully, as you've watched the video, you've seen the experiment with 3 different types of exercises: the walking, the jumping, and the running. So if you've watched the video, then you should have made a table like this. There are 3 different exercises, so I've put these along the top. For each, we need to have 3 people: Tono, me, and Lala. For each exercise, we should have 3 columns: heart rate before, heart rate afterwards, and the difference. So before, after, difference, and before, after, difference. And if you watch the video, then you should be able to complete all these different numbers. So that you can see for Tono, after he did the first exercise, his heart rate went down, but both me and Lala, our heart rates increased a little bit. For the second exercise, all 3 of our heart rates increased. Lala's increased more than the easy one, and mine increased more than the easy one, and well, Tono's went up instead of down. And then for exercise 3, well, Tono's went up again, Lala's went up again, mine went up, but not by as much this time. So did it prove the hypothesis? And the hypothesis was that the more intense the activity, the greater the increase in the heart rate. Well, for Lala, +6 + 15 + 21. For Lala, it definitely was more intense, more increase. For Tono, it did go up, but there is a problem result. This first one of -27. This should not have happened. If he had a resting heart rate of 97, after walking, his heart rate should have gone up, not gone down. So we have a small problem with those results. For mine, well, they did go up, but not by what we would expect. The second one went up more than the other. So we can say it partially proved the hypothesis, but there are some mistakes. Can you remember the experiment? What things in the experiment do you think might have caused the results not to be what we expected? Now, there's no problem. If your results don't match your hypothesis, what you do is you go back to the experiment and you think, what errors could there have been? What bias could there have been in the experimental method? For one thing, if you remember, I was talking to you while they were measuring my resting heart rate. If I'm talking, I'm using more energy. So maybe my heart rate did not go down enough. And we can see my heart rate was normally 74, 75, but after the third one, it was only 91. It was actually higher than it should have been. So maybe because I was talking to you, that affected my heart rate. So if we're going to make it fair, maybe nobody should have been talking during that 1 minute when the heart rate was being tested. Maybe different people counted less accurately. You saw me joking with Pecan in the video. Maybe Pecan was struggling to find the pulse. Maybe he was making it up or not feeling where the pulse really was. Now, somebody was saying stop. But somebody actually on the second one, they stopped it a little bit early. And I said, maybe we stopped 4 seconds early, so we have to increase it a little bit. So not starting and stopping exactly on 1 minute would definitely affect the measurement of the heart rate. And maybe you could say not enough rest time. Maybe we should have had more time to rest in between each of these different activities. If I asked you how could this be improved, well, one way we could improve it would be to use a machine like in the hospital, to put the patch around the arm and then to test the blood pressure using a proper machine rather than by counting. That would improve the accuracy of measuring the heart rate. Now, let's go and look through the answers to the quiz that I set you in the Google Forms. Questions 1 to 5, they're all based on this experiment. So question 1, what was the independent variable? That is the thing I change. That's the thing that I, as the scientist, changes. Did I change the length of time for exercising? No. For walking, jumping, and running, it was all 1 minute. We kept it 1 minute every time, so this was controlled. Was the heart rate of the individual after exercise something that I can change? Could I make Tonor's heart beat faster or slower? No. This is something that was measured. It's not something that I could control. The type of exercise? Well, the type of exercise was the same. Was it? No. Okay, we had 3 types of exercise. We had walking, we had jumping, and we had running. I said, now we walk. I said, now we jump. I said, now we run. So I changed the type of exercise. So the correct answer is this one here. This is the independent variable because this is the thing that I was changing. The heart rate of the individual before the exercise was measured, but it's not something that I could physically control or change. What was the dependent variable? Now, dependent variable always means the thing that you measure, the thing that is affected by the independent variable. If you see IV, it means independent variable. If you see DV, it means dependent variable. So the person checking the pulse, this was not measured. This is not actually a dependent variable. The length of time exercising, this was always 1 minute. This was controlled. The type of exercise, well, that was the independent variable, so it cannot also be the dependent variable. The change in the heart rate was measured. The heart rate was affected by the type of exercise. So the independent variable affected the change in the heart rate. So in this example, the change in the heart rate would be the dependent variable. So what is one possible source of error in the experiment? Walking does not use enough energy to make a change. Well, all body actions need energy, so any type of exercise would make some kind of change. Different people checking the pulses may be more or less accurate than each other. Yeah, checking a pulse is not an easy thing. It takes doctors a long time to practice. Maybe some people have had practice before, other people have not, so some people were more accurate. 3 people doing the experiment was an important thing because by having 3 people, you had repetition. Sometimes one person might do the same thing 3 times in a row. This is a good way to get an average. But if you have 3 different people doing it, it's another way of repeating the experiment and seeing if the results are accurate and valid. So this was a good way to increase the accuracy. And there was time to rest between each activity that was necessary for the heart rate to come down again. Which of the following was not controlled in the experiment? The time doing the exercise was 1 minute every time. The time checking the heart rate was 1 minute every time. The resting heart rate was checked, or the accuracy of the person checking the pulse. This was not controlled. We could not control how accurate the person was. If we use the machine, we would get a more accurate reading. If there was no time to rest between each activity, the experiment would have been less valid. Which of the following does not support this statement? The heart rate would be affected by the previous activity. This would mean the results were less accurate. So this does support the idea. The difference in the heart rate could be because of the old activity or the new activity. If there was no time to rest, then any changes could be because of the jumping or the walking before, not the thing that they are doing then. So this would support the experiment. People may become tired and start to respire anaerobically. Remember, in anaerobic respiration, glucose is broken down without oxygen to release energy, and lactic acid is produced. So if it's without oxygen, this is not going to be affecting the heart rate. So if people were too tired to do the activity, you saw PP, maybe when people get too tired to do the activity, their heart rate slows down because they start to respire anaerobically. So that also supports the statement. It would not be possible to find the difference in heart rate. Is correct. It wouldn't be possible to find the difference in heart rate. If there was no resting between each one, we would not know what the starting and finishing heart rate was. We couldn't subtract, we couldn't find the difference. So the resting period was very important. Checking the heart rate was very important because it allowed us to find the heart rate change. Now, the next 5 questions are not based on this experiment. They're based on different ideas. So an experiment is performed on plants to see how different liquids affect plant growth. We're looking at different liquids and we're looking at plant growth. Each plant in the experiment is given a different liquid: water, apple juice, or milk. Each plant has the same amount of soil, that's controlled, the same amount of sunlight, that's controlled, the same amount of liquid, that's controlled. What is the independent variable? Well, the plant growth will be measured. So the plant growth would be the dependent variable. They're given a different liquid. That means the person doing the experiment is choosing to change the type of liquid. This is changed by the scientist. So this is the independent variable. So the type of growth, the type of liquid is the correct answer. Plant growth, dependent variable, type of plant is controlled, and amount of sunlight is also controlled. Mr. S set up an experiment to see how the mass of a ball affects the distance it rolls off a ramp. What is the dependent variable? Well, there are 2 things mentioned. The length of the ramp and the height of the ramp are not mentioned in the passage, so we can assume that these will be controlled. We have the mass, the weight of the ball, and how far it travels. Well, this is what we're going to measure, and this is what we're going to change. So the mass of the ball is going to be the independent variable, and the distance it rolls is going to be the dependent variable. So the distance traveled by the ball is the correct answer. Now, what is a valid hypothesis for this example? Alia wants to investigate if the amount of fertilizer used on a field will affect the number of earthworms found there. So a hypothesis is a guess. Often we see it as if this happens, then that will happen. A hypothesis is never a question. Asking a question is the first thing that we do. We want to know how earthworms live. Can they live in fertilizer, for example? Fertilizer kills earthworms does not focus on the amount of fertilizer. The amount of fertilizer is going to be the dependent variable. So the amount is going to be changed. And we're going to be counting the number of earthworms. So there's got to be something about the amount of fertilizer and the number of earthworms. The first one, if there are earthworms, then there will be fertilizer, has both the ideas and it has the if and then, but it's not the correct connection. The person doing the experiment is going to change the amount of fertilizer. So the amount of fertilizer, is going to be the independent variable. The number of earthworms is going to be the dependent variable. This is what's going to be measured. This is saying the other way around. The second one, if the amount of fertilizer is increased, then the number of earthworms will decrease. So when one goes up, the other will come down. When we change the independent variable, the dependent variable will decrease. This is a good hypothesis because it's making a prediction about what will happen. Number 9. What is a valid hypothesis for this experiment? Dante wants to investigate if the amount of oxygen in the water, so we're looking at the oxygen in the water, will have an effect on the oyster population. Now, the second one has to be wrong. A hypothesis is a guess, it's not a question. So we can take this answer away. Oysters will turn blue when exposed to oxygen. Well, this is not about the amount of oxygen, okay? And there's nothing about color in this explanation. So the idea of the color and is not there, and exposed to oxygen doesn't talk about the amount of oxygen. So we can take this one away. So now we have 2 answers left. If the amount of oxygen in the water is decreased, then the number of oysters will decrease. This is making a prediction. If there is less oxygen, there will be less oysters. It's a prediction about what will happen. This is a good hypothesis. The last one, if there are oysters, then there will be less oxygen. But this is the wrong way around. The oxygen is the independent variable, and the oyster population is the dependent variable. The independent variable, the thing the scientist changes, affects the dependent variable. It's not the dependent variable affecting the independent variable. The effect on the oyster population is what the scientist is watching and counting. And that happens because they change the amount of oxygen. So it's just the wrong way around. Okay, last question. Do you remember the scientific method? You ask a question, you collect some information, you make a hypothesis, you do an experiment, and then you make a conclusion. Now, Maria wants to know if tomato seeds grow faster than mango seeds. She then asks her father, which is a farmer, about her question. Which steps of the scientific method does Maria perform? So, she asks her father a question. This is not doing an experiment. There's no test happening. And it's not making a hypothesis. She's not guessing. She's not saying it will be quicker or slower. She's asking a question. So it's also not going to be a conclusion because she's still trying to find information. This is the background research stage. She's collecting data so that she can make a hypothesis. Later, she might plant the 2 types of seed, watch them grow, and then make a conclusion. But at this stage, she's collecting information that is already available. And in this case, she's asking somebody. So the last one is correct. Okay, hopefully that's helped you a little bit. We'll keep going with these lessons on scientific method. We'll keep reviewing the independent variable, the dependent variable, control, sources of bias, forming hypotheses, because these type of questions are definitely going to come up in your exam. Also, la Psychodet.